Hello, LG2 students. The next and final chapter that we're going to get into is dealing with rational functions. And if you remember, the word rational, when we talked about rational numbers, means fractions. It's another word for anything you can turn into a fraction. So we're going to look at functions that are in fractional form. And this first lesson today is meant to basically just give you an idea of what they are and what they look like in terms of graphically, and then we'll go more in depth on the next lesson. But if you take a look, they call it the reciprocal function because it's the reciprocal of x. It's 1 over x. So if you notice, here's your general form equation. If you remember back to a, h, and k, the reason it says a cannot equal 0 is because if a equals 0, remember 0 divided by anything gives you 0. So then this whole thing would equal 0 and you don't have your rational function anymore. And x cannot equal h. The reason for that is you would end up with 0 in the denominator if those two are equal. And remember, you can't divide by 0. Okay. So if you take a look at that, notice a cannot equal 1 as well. Again, it wouldn't quite be the same way here. So you'd end up with a over x if both h and k, your horizontal and vertical shifts, were 0. If a does equal 1, this is kind of your parent function, if you will. Okay, this is the parent function that we're going to work off of, these two basic ideas, and that's what we're going to look at today. Notice there's going to be a horizontal asymptote at y equals k. So wherever your vertical shift is, there's a horizontal asymptote that shifts with it. There's also going to be a vertical asymptote at x equals h. Okay, wherever would make the denominator equal to 0 is where you're going to end up with a vertical asymptote. Okay, whatever value of x. So if we take a look at the first problem here, when I ask the graph of this y equals negative 5 over x, basically they said let's take a look at an a, h, and k form. Okay, so a is negative 5, h is 0, there is no horizontal shift, and k is 0, so there is no vertical shift. So if you take a look, the first thing you always want to do is identify your asymptotes, the vertical and the horizontal one. And so in any parent function, your horizontal asymptote is going to be at y equals 0, the x-axis. Okay, and the parent function for a vertical asymptote is at x equals 0, which is the y-axis. And then from there, these two vertical asymptotes are what get shifted. You basically are shifting those axes, if you will. Okay, and then the rest of it in step 3 here, basically to figure out where your graph is located, they're basically just saying, let's pick some points on either side of my vertical asymptote here and figure out whether my graph is above or below the horizontal asymptote. Okay, so that's what this table is doing. They're picking a couple of negative values, and notice the y values are positive, so you notice that there's a curve right there. And then they pick some values on the other side of the vertical asymptote, some positive ones, end up with negative values for y. Okay? One of the things that you will always notice when you're dealing with these graphs is that they always alternate. Okay, so in this case, they're opposites of each other. If this one's above, on the other side of the vertical asymptote, it's going to be below. Okay, so that'll always happen when you take a look at that. So for these first 3 problems, that's what you're doing. Identify your vertical and horizontal asymptotes, and then pick some points to kind of see where the graph is located. Is it going to be located in these 2 quadrants, or will it be located in these 2 quadrants, okay, that are bounded by your 2 asymptotes? Keep in mind in number 3, you just need to get it to look, you got to divide both sides by x first to get it to look like numbers 1 and 2 before you graph it. Okay. Then if we take a look at the back side, the only difference is those first 3 problems, they didn't give you any horizontal or vertical shifts. The difference on the back side is that they did. Okay, so for this first problem, what they're having to take a look at is a is negative 6. Notice they took the negative that's out front and they just moved it, included it with the 6, which is perfectly fine. Your horizontal shift is negative 3. If x equaled negative 3, you'd have 0 in the denominator, and anytime you have the denominator equals 0, you have a vertical asymptote. Okay, and finally k is 2. Okay, there's your plus 2 right there, so you've got a vertical shift up 2. So if we take that information and we move our asymptotes now, normally these are the x and the y axis, but I'm going to shift them 3 to the left and up 2. So if you notice, where they normally would have crossed was right here at the origin, but we went 3 to the left and up 2, and now that's where they cross. Okay, you're just shifting those asymptotes. And then once again, to figure out where your graph is located, pick some points on either side of the vertical asymptote. Okay, so for example, notice that they picked -6. Okay, in the problem, and they got a y value of positive. Hang on. So here's what this is saying. I misread this. So here's what they're saying is these would have been points on the original function. Okay, these are your translated points. Okay, after you moved them all. What I would say is just you don't have to worry about this first part. Just go ahead and just pick some points on either side of the vertical asymptote, and then it'll tell you where these graphs will be located. So when they pick -9, you end up with a +3 as a value, which happens to be above the horizontal asymptote. Pick -6, you end up with 4 as an answer, also above the. So I know right away that this graph is right in this vicinity, which also then should tell me that the other graph should be diagonal from it in this vicinity. Okay, but you're looking for pick x values on either side of the vertical asymptote, and then check to see if the corresponding y values are above or below the horizontal asymptote. And that will guide you as to where your graph is going to be located. Okay? Again, you could have had it was possible to be right in this case as well. Okay, matter of fact, if that would have been a +6, that's exactly where your graph would have been. You would have had a graph right here, and then the other part it graphed here. Okay, and so 4, 5, and 6 on this problem are very similar to what you were doing before. One thing to take a look at is on number 6, you need to get it into this format before you can go through and do much with it. Okay, so what I would suggest you do on number 6 is go through and get a common denominator first, so that you can then try to combine these two into one. Okay, and then you can go from there and see what you come up with. Okay? Otherwise, but I would say the first 5 problems are really the ones that you're taking a look at. Those are the ones I really want you to focus on. Remember, this is just an introduction to what do rational function graphs look like, and a little bit with horizontal and vertical asymptotes. Okay. As always, if you have any questions, don't hesitate to contact me and let me know what's going on, and we'll get everything figured out. Okay. Have a good day, everybody.